Alright y'all, we're going to tackle goal 2.05 to be able to factor the difference or sum of perfect cubes. Now, before we get started, we need to get very familiar with what a perfect cube is. All it is a number that has three factors that are the same thing, okay? So like think about 2 times 2 times 2. 2 times 2 times 2, it's 2 times 2 is 4, times another 2 is 8, okay? Meaning 8 is a perfect cube, okay? So let's just talk about the first 10 perfect cubes. 1 times 1 times 1 is 1. We already said 2 times 2 times 2 is 8. 3 times 3 is 9, times another 3 is 27. And as you can see, I spaced these out a little bit more as I went along because the numbers get pretty big pretty quick. 4 times 4 times 4 is 64. 5 times 5 times 5 is 125. 6 times 6 times 6 is 216. 7 times 7 times 7, that is 343. 8 times 8 times 8, that is 512. 9 times 9 times 9, or 9 cubed, that is 729. And 10 cubed is 1,000. Okay, now there are other perfect cubes, obviously, like 11 cubed and 12 cubed, but we're just going to look at the first 10 because they seem to be the most common. Alright, now, whenever I say the sum or difference of perfect cubes, I mean if I have one perfect cube plus another perfect cube, or one perfect cube minus another perfect cube. You notice I have A and B here? That's just because this rule works for any number plus or minus any other number so long as they're both perfect cubes. Okay? So the rule is these two terms will split into a binomial times a trinomial. So a two-term thing times a three-term thing. Okay? That's true for addition and subtraction. Now you may be wondering, why does Mr. Canterbury have the word soap written down there below everything? Soap is actually this really helpful little trick to help us remember the signs, meaning plus or minus, okay? Because there's two terms here, we're going to have either plus or minus there. Three terms here, so there's two more plus or minus signs here, okay? SOAP stands for something. It stands for same. The first sign in the binomial is the same as whatever you started with. So if you were adding, the first sign is plus. If you were subtracting, the first sign is minus. Easy so far. O stands for opposite. So if you started out by adding, you have a minus here and a plus there. Okay? And the last one, we got one more sign connecting the second and third term from the trinomial. Okay? The last sign is always positive. So no matter what, the last sign is always a plus. Okay? Now we just got to figure out what these five numbers are, and they're really, really easy. Okay? They all follow this pattern. The first number is the cube root of this number. Okay? The cube root of a cubed is obviously just a. The cube root of b cubed is obviously just b. And that's the same for the sum or difference of these cubes. Now, to get the first number in the trinomial, you really just look at your binomial. The first number in the trinomial is the first number in the binomial squared. A squared. And the last number in your trinomial is the last number in your binomial squared. And the middle term is just these two numbers added, or not added, multiplied together. AB. Okay? If you can remember those two formulas, you will be able to do this so easily. Okay? Try to memorize your perfect cubes. If not, I'm going to show you a calculator trick in a minute. But let's start working some examples. So let's say I gave you 343 plus x cubed. I'm just starting off kind of mean and putting the x cubed in the back. Okay? The answer would be a binomial times a trinomial We started out with the plus sign, so our first sign is the same. Since we start out with the plus sign, our second sign has to be the opposite, and our last sign has to be always positive. Now, the cube root of 343. Looking back up here, we know that 343 is a perfect cube of 7. So this is a 7. The cube root of x cubed is just x. Okay, the first number in my trinomial is the first number here, squared. So 7 squared is 49. My last number is the x squared. And my middle number is just 7 times x. And boom, that's your answer. Okay, let's try another one. How about x cubed minus 729? Draw your binomial and your trinomial. First sign is same. Since we started out with subtraction, we have a subtraction sign. Then a opposite sign. And then that last sign is always positive. Cube root of x cubed is x. Cube root of 729, looking up at our little table here, is 9. Okay, x squared is our first term in our trinomial. X times 9, or 9x, is our middle term. And 9 squared is 81. Boom, that's it. Nothing left to do here. Now, I have a fun problem next. You ready? How about, let's go with y cubed minus 46,656. That's a big number. Do you see that in our table? No. I will guarantee you that is a perfect cube. Okay? So, what do you want to do? Do you just want to keep on cubing numbers until you find 46,656? Or your calculator will take the cube root of a number for you. Okay? All you do is hit the math button and the fourth option. It looks like it says 3 square root parentheses. That 3 is your index. It's taking the cube root. Let's take the cube root of 46,656. Boom. Cube root is 36. Now this just got a lot easier. Okay? We will split this into our binomial times our trinomial. We're going to say minus first, plus plus, same sign, opposite sign, always positive sign. And the cube root of y cubed is y. Cube root of 46,656 is 36. Then you just work off the binomial, y squared plus 36y. Then you got to square 36, and quite honestly, I don't know that in my head. It is 1296. And that's your answer. It's as easy as that. Okay? Now, remember your exponent rules, okay? If I gave you, let's think of another letter. How about z to the 9th power? Plus k to the 30th power. Those are both perfect cubes. And I know you're thinking, no, 9's not a perfect cube and 30's not a perfect cube. They're exponents though, okay? These are perfect cubes and they will factor using this formula. Almost forgot that last one's always positive. Okay, z to the 9th. That is z times z times z times itself 9 times. Okay? Let's write that out. Looks like I'm falling asleep here. I'm a nerd and put a little line through my z's so they don't look like 2's. Okay, that is 9 z's. But I could kind of group these strategically and think about these are 3 groups of the same thing. And remember, that's what a cube root is. 3 numbers of the same number that multiply to give you your original perfect cube. Well, z times z is z cubed times z cubed times z cubed equals z to the 9th. So the cube root of z to the 9th is z cubed. Quicker way to think about it, divide the exponent by 3. Okay? The cube root of z to the 9th is z to the 3rd. The cube root of k to the 30th is k to the 10th. Okay? Now we're going to start building these up. Z cubed squared, think of your exponent rules. Squaring something means multiplying it by itself. If I had z cubed times z cubed, it would be z to the 6th. K to the 10th squared is k to the 20th. And then the middle thing is just z cubed k to the 10th. And as ugly as that is your answer. Alright, thank y'all for watching. If you have any questions, email me.